Okay, so what is speed? It seems obvious. It's how fast you're travelling. But let's think about this a little bit further, a little bit deeper. Let's take two cars. One is speeding, the other's not. What's the difference between those two cars? To help explain this, I'm going to introduce you to Sammy. Sammy, the super snail. She goes for a slide. How can we figure out how fast she's travelling? How can we figure out her speed? We need to know two things. One, we need to know how far she's travelled. We're going to call this distance. And we need to know how much time she took to cover this distance. Using these two figures, for example, Sammy covers 10 metres. We're going to use metres here because to scientists these are the most useful units. She covers the 10 metres in 10 seconds. We're going to use seconds also because they're very useful. So how fast does she travel? We take the distance, 10 metres, and divide by the time, 10 seconds. 10 divided by 10 is 1 metre per second. Okay, the next day, after eating her way through my lettuces, she does the same 10 metres, but in 5 seconds. Is she faster or slower? Well, let's find out. We take the distance in metres, 10 metres, divide by the time in seconds, 5. 10 divided by 5 is 2 metres per second. She's twice as fast. Obviously, very delighted with this. Okay, so let's go back to the cars. The speeding car will be covering the same distance in less time compared to the safe motorist. Although scientists prefer meters per second, any combination of distance and time, depending on what's useful to you, would be acceptable. So for example, if we want to know how fast the tectonic plates move against each other, we could use a unit more like centimeters per year, but it'd still be acceptable.